Um, Before we start the video, there are a few disclaimers that I need to make. The first disclaimer is that I am not a professional in this domain, right? I am a college student, and so take everything that I say with basically a pinch of salt. And if you wish to dig deeper or explore more, you can do that. You can look at secondary sources or you can learn from somewhere else, right? My main goal today is to basically demystify the domain a bit, right? All of the magic and trickery behind AI. I want to kind of clear the fog a bit and actually show you that it's pretty simple stuff, right? Stuff that anybody can understand. The second disclaimer is going to be the fact that this video is probably going to remain unedited, right? I'm not going to edit this video because of a few reasons. The first reason is that I don't expect a lot of people to see this, right? Maybe a few. So if this pops up on your feed and you're like, I'm a non-technical person, I don't really understand how AI works and all of this and all of that, and this person is here to teach me. So if you click because of that, this video is for you. So the third disclaimer is going to be that my native language is actually Hindi. I'll be communicating in English today because I want to communicate to as many people as possible. And I don't want there to be a language barrier. But if there is any lack of communication or any concept or anything that I'm not about to, that I can't communicate clearly, I would like to apologize for that because of this fact. So, yeah, I think with that, we can start the video. All right, I'll just put myself right here. This should be a good spot. And so, yes, the first thing that we're going to tackle today is what exactly is artificial intelligence, right? This word has been thrown a lot nowadays, right? You hear this every day. Artificial intelligence is doing this, it's doing that, and for a non-technical person, right, this is very overwhelming, right? Because you don't know how it works. You don't know anything about the domain. Maybe you don't have a mathematical background, you don't have a computer science background. So for you, it is going to be like an avalanche, right? An avalanche of information and like job is going, they're taking my jobs and all of this and all of that. A lot of panic. So that is the current problem, right? So what I'm going to basically do is I'm going to clear all of that and I'm going to try to help you understand what exactly it is and how it works. So, okay, artificial intelligence is the definition of it is mimicking human intelligence. That is all it is, right? So, if you mimic anything that a human does, it is technically considered as artificial intelligence. So, to help, let me just draw something right here, right? Let us put the entire domain of artificial intelligence into this little box, right? Intelligence. So, this is what it is. If you, it, this, okay, to clear something up, if you're thinking about neural networks or you're thinking about transformers or big architectures or all of this and all of that, when you hear this word, that is not true. It exists in this domain, but this is not all it encompasses. If you write an algorithm, right, that somehow mimics a human, right, just any algorithm, a deterministic algorithm, and it mimics anything that a human does, maybe thinking, maybe decision making, anything, right? That is considered artificial intelligence. So for this, you usually need a computer, but the way you go about it is not limited. You can use deep neural networks, you can use simple architectures, you can use like normal mathematics, and all of it works. So that is what artificial intelligence is. Now, inside artificial intelligence, we have another domain. This is what we call machine learning. So some people, if not a lot of people, are going to be familiar with these words. Now, machine learning comes under artificial intelligence. And what this basically domain is, it uses data to teach computers to perform tasks, right? What is machine learning? You are teaching a machine to do human tasks or to mimic human tasks using data, right? This is where all your statistical methods, all of that stuff comes in. All of the algorithms, all the computational stuff is usually under machine learning, right? So that is what machine learning is. And we have One final domain inside of it, this is the fun one, right? This is the one where all the hype is at. See, deep learning. What is deep learning? Deep learning is a subset of machine learning. Now, as I said, machine learning is just, it uses all statistical methods. All the statistical methods that are going to use data to perform tasks is going to come under machine learning. So, out of those, if you are specifically using deep neural networks, now, a deep neural network is one such statistical method, right? There are a lot more. If you're using deep neural networks for the tasks of machine learning, it is going to be deep learning. Now, you might ask, uh, like deep learning is such a huge domain, right? If you're saying that there are so many other statistical methods, why is this specific one so popular? Why is it such a big deal? Right. This mainly is because specifically neural networks scale very well, right? Now, the other architectures or the other methods, right, they are very good. But at some point, they start hitting a scaling problem, right? So if you have an absolutely humongous amount of data, some of those, they might work, but they might not train very well. They might not give very, good outputs. Their training might degrade. They might be poisoned. A lot of things. But the deep neural networks are extremely resilient, right? And they scale very well. So since we have petabytes of data across the internet, not even petabytes, yottabyte, exabytes, I don't know, absolutely humongous amount of data on the internet, these architectures have taken the stage and are currently being used. So this is the pretty much the Venn diagram of artificial intelligence. So once again, let me clear it up. Artificial intelligence, anything that we use to mimic human nature, be it machines, be it computers, be it algorithms, anything, right? Mimic human nature, it is artificial intelligence. If you use a machine, and if you machine as in a computer, if you use a computer and if you use data to perform this task for training the machine, it's called machine learning. If you use specifically deep neural networks along with data to train a computer to do tasks, it is called deep learning. So this is something that you need to know. Now, all of the transformers, right? All of the LLMs, all the Chat GPT, all the Vision, Gemma, Quen, DeepSeek, all of this stuff resides in this domain, right? All of your LLMs reside here. LLMs, large language models, vision language models, all of that stuff in the current domain resides here. So, all right, that is going to be a basic understanding of the domain, right? Now, next, what we have to come to is what exactly is machine learning? Now, since artificial intelligence is such a huge domain, I am going to restrict what we are going to learn, what I'm going to talk about, to machine learning because that is where all of the hype is currently. So, for machine learning, okay, you have to realize for the task of machine learning, three things matter. All right, there are only three things that you need to know about. The first one is your input data, right? The second one is your black box, and the third one is your output. Right? This seems very simple, and it is. So, what you should know is that most of you know pretty much machine learning, right? Most of what machine learning is follows this simple pipeline. You have your input data, then you have a black box. Now, what exactly does a black box means? A black box means you can basically all the statistical methods that you're going to use, all the architectures, all of the mathematics that you're going to use exists within this. Okay. So if I'm using neural networks. This person is using something else. That person is using linear regression, right? Only difference between us is if you're using the same data, we're just using a different box, right? That is all. We're just treating the data differently. So You have the input data that is going to be transformed by the black box into the output data, right? Another thing that you have to understand, no architecture like this does not make sense, right? All architectures, all methods in the domain of machine learning transform data, right? They do not create anything from scratch. They only transform your input data. All right. So without this, nothing works. Now you may be like, okay, well, what about vision generation models, right? Models that create pictures, right? They're generating something from scratch, of course, right? They don't need an input data or something like that. That's actually false. Even those are actually only manipulating the data. They're only transforming the data. They are not creating anything from scratch. So you need to understand this properly. These three things are required in the domain of machine learning. Now, firstly, what we're going to talk about is your input data, right? One thing you have to understand is that computers work with numbers, right? Every, like, if you're writing text, if you're typing on your keyboard, you'll be like, okay, well, if I'm writing an Excel sheet or if I'm writing on my notepad, that is text, right? So the computer is working with text. That is actually not true. Everything, in the underlying layer is treated as numbers. So for any form of input data that you're going to feed to this black box, this is where your model lies, right? This black box, you can also call it the model, but I'm calling it a black box because you can have multiple models that you can have whatever you want, right? For any form of input data, it needs to be numeric. It needs to be formed of numbers. You cannot pass the word hello to this black box. You need to convert it to a number because, as I said, these are statistical methods, and statistical methods only work on math. They only work on numbers. So what you do is, if you have any data, you have to convert it to a numerical format before you pass it to this black box. This black box or this model or this set of models, whatever you use, are going to transform. Now, what exactly does transform mean? Transform simply means modify the data, right? It is going to perform mathematical augmentations to the data and simply give out an output. So this mathematical formation of your data is going to be passed to the black box. This is going to modify, transform, or augment the data to give out the output. This output is also going to be numerical in nature. Now, and a simple example. Okay, let me use input data. Let me use the number 5. Oops, right. This is our input data. Now, let this black box be the equation x plus 5. Okay, now what does this mean? I simply have a formula inside that takes an input x, that is the number. Your input data is x. It takes the input data, it adds 5 to it, and it gives it out. So you're going to pass this data in here, and what output is it going to give? It's going to be 10. This is a very simple example of what is actually going on here, right? So these are the three main steps. Now, what you have to, another thing that you have to realize here is that, okay, your data, right? What you can do is, um, instead of a single number, right? Okay, let's go. Okay, how do you actually transform? Like, how do you convert your input data into this numerical format? Right? You must be thinking of that. How do I actually do that? How do I convert the word hello into a number? I'll give you a simple example of that. Let's just call it a black box. Okay, so initially we have the word happy, right? Let me assign this word to um okay, let me assign this word a vector 0, 0, 1. Okay. Now, what is a vector, right? This is basically I'm assigning the numbers 0, 0, and 1 to the word happy, right? So wherever I see the word happy, I am going to simply just convert it into the number 0, 0, 1. Okay. Then I can be like, okay, let me, for the word sad, let me use the words 0, 1, 0, right? And let, I don't know, forlorn. For this word, we can use 1, 0, 0. Right? So in this way, we are mapping a word, a text to a number. So if you want to feed the data happy into this model, right, into this pipeline, you are actually feeding the numbers 0, 0, 1. And what this could be is, right, if let's say in this representation, the first number is considered X, the second number is considered Y, and the third number is considered Z, let it give the output, let the black box be giving the output equal to X plus 5, Y plus 5, comma Z plus 5. So what we're going to do is we're going to pass it the word happy, and what are we going to get? We are going to get 5, 5. Okay, so all right, what does this mean, right? Let us use another example. Instead of x plus 5, y plus 5, z plus 5, let us use x, y plus 1, and z minus 1. All right. So if we pass the word happy to it, initially happy is going to be replaced by its numerical um, representation, that is 0, 0, 1. It is going to be passed. Now x is 0, so the output will remain 0. Y is 0, so the output will remain y plus 1, so that is 0 plus 1. And z is 1 here, so z minus 1. Here we can see that the output is going to be 0, 1, 0, which we, when we reverse map just means instead of going from text to number, you just go from number to text. Go from number to text. It actually turns out to be the word sad. So in our pipeline, gave in the word happy, and we got the output sad. Now you can, what you can do is you can call this black box mood flipper, right? So you give me a word, and I'm going to give you its opposite, right? And you can do something like that. This is a simple example of what a machine learning pipeline can look like, right? So, right, a lot of, you have to realize a lot of research is being done on the input data, but most of the research is actually being done here, right, in machine learning, the black box. How do you actually transform or augment the input data, right? So the more complex, now as you can see right here, in such a simple like manner, in like what 30 seconds, 1 minute, we have made a model that flips emotions, right? You give in happy, it's going to give out sad. Now if like this itself is pretty impressive, right? If we scale this, it is pretty impressive, right? So with this simple form, now if you realize the fact that if instead of this black box we have something that is extremely complicated, have let's say a deep neural network, we have architectures that are running on thousands of GPUs, I think you can realize the scale of uh, the potential here, the potential of this pipeline, right? That is actually what all of AI is currently betting on, right? So we are investing on making a bigger black box. We are investing on making a more complex, highly robust, an absolutely humongous black box so that we can get better outputs, right? And this is actually how all of the current large language models work, right? So if you are investing in AI, this is probably what you're investing in, right? This simple pipeline. Your money is probably going to into making a bigger black box, a larger neural network, right? So since as I said, we can use anywhere here. Currently, we have used a simple formula. One way of doing it is using neural networks. Another way is using linear regression, decision trees, SPMs, a lot of methods that you can go through, right? But what we have to realize is all of these methods, everything, if I say a decision tree, I say SVMs, I say neural networks, transformers, convolutional neural networks, vision transformers, anything, all it is doing is augmenting this input. It is converting one number or one set of numbers into another set of. All right. This is what machine learning is. So it can be considered as a mapping from one set of numbers to another set of. Now, the beauty of it is you can fix this set of numbers as your input data, but you can use anything you want as the output, right? Because this model is just going to give x, y plus 1, z minus 1. You can decide what the output mapping, like you can be like, okay, I don't want to use the same mapping. Let me actually use for the outputs. Okay, let me use very sad, very happy, and eh, right. So now you can be like, okay, I gave in the word happy, right? It was converted into 001. It was given into the black box, let's say our neural network, right? But the simple formula, we got the output 010, if you can remember, right? This output comes 010. And now you can be like, okay, my output from my black box, my model, right, was very happy. So what I have created is a model that amplifies your emotions, right? You put in an emotion and it amplifies. Simple, right? So you can choose what mappings for the output you want. You can choose what mappings for the input you want. This is a basic introduction to machine learning. Now, coming on to some architectures. Long this video currently is it's 22 minutes. Okay, we'll probably do learn a bit more for like 10 or 15 minutes, then I'll stop. Okay, so moving on. Coming on to architecture, right? Some black box architectures are um, instead of you can use deterministic form, right? So what is a deterministic formula? It means a formula that deterministic means there is no randomness to it. If I said the formula is x, y plus 1, z plus 1, it is always going to be x, y plus 1, z plus 1. There is no randomness. If you give in the same input 100 times, you are going to get the same output 100. That is what a deterministic mathematical formula means. You can have deterministic formulas. You can go a bit further. You can be like, okay, let me linear regression, right? We're going to probably, hopefully, going to get into these as well. You can use logistic regression. You can use decision trees. We can use support vector machines. Now here comes the fun part. We can use neural network. And in neural networks, like I honestly consider it a subset of neural networks, but I should write it right. Transformers, convolutional neural networks. These are some black box architectures, right? So you have to realize that all of this is simply going to remain in here. You can swap out anything for anything. So if someone is using linear regression, you can be like, okay, I actually have a lot more compute. I have a lot more. I have a much stronger computer. So instead, let me use neural network. It it's not going to be like a completely new pipeline or a new architecture or a new way of looking at it. You're just swapping out the black box for something better or bigger or something that you think scales better or performs better. So these are some of the architectures. Coming into um, our input data, right? Okay. So another thing that you have to realize, right, if you are a non-technical person, is I just told you that you can convert your words into these numerical representations, right? Now, in the field of machine learning, this process, this exactly what I've told you, this is called one-hot encoding, right? One-hot encoding. Now, if I just told you, just take your words and just one-hot encode it into vectors and just use that, right? You wouldn't understand anything. You would be like, okay, this is completely out of my domain. I understand absolutely nothing yet. This must be something silly. But once I've told you how it works, you realize it's actually very simple, right? So what my aim is going to be is to explain things first and then give you their complex names and all of that, because that is truly what is scaring a lot of people, right? Using these big words. Well, I'm actually using, I don't know, okay, kiwi caching, using this and like latent attention and this and that and all of that. It's pretty easy, right? It's all very simple, nothing to be scared of, and you can learn it without knowing. So this is a little bit of demystification, right, of the current AI domain. And this, what I've currently explained, this pipeline, this architecture, we are still using. We have been using it decades. We are still using it. All of the marvels of AI, all of the extremely impressive stuff in AI is still using it, right? What they have done is they have scaled this input data humongously. They have scaled this black box humongously. And due to that, we are getting very impressive results. But at the end of the day, you have to realize all that a trans, right? ChatGPT, right? Let's say it's a mixture of experts, I don't know, shifting window transformer, all of this and all of that. Yeah, right. All it is all it's performing is mapping one set of numbers to another set. Why does it need to be so huge? Why does it need to take the energy of an atomic bomb to train? It is because the input data is so much, right? It needs to deal with text, it needs to deal with images, it needs to deal with documents, and there are infinite possibilities for all of those. And how do you do a single model to perform well across all of this? In it, you make it absolutely disgustingly huge and you train it for absolutely disgusting amounts of time on an absolutely disgusting amount of GPUs. All it is doing. All right. So what you're being impressed by, what you're being sold to today is this at a much larger scale. There is no new magic, there is nothing new. But obviously, this black box is very simple. Once we learn about neural networks, learn about CNNs, transformers, state-space models, all of this, all of that, you're going to get a better picture, right? Don't get scared by all of these words. It's actually pretty simple, right? If I make videos after this as well, uh, I'm going to keep it as simple as possible, right? Don't get scared by all of these words. It is very intuitive. So yes, this is going to be the first video. If you enjoyed it, kindly write in the comments if you have any questions or if you have any recommendations, if anything was lacking in this video. So yes, with that, thanks for watching and I'll hopefully see you in the next video.